In this video, we are going to continue our work with addition and subtraction, working with both mental math and estimation. All right, let's start with mental math. So in mental math, the goal is to get the correct right answer. It is not an estimation technique. You want to get an exact answer. You just want to try to find an easy way to do that. These are for things you're trying to do in your head. You're at the grocery store trying to add things up, or you're at a restaurant trying to figure out how much the tip is, something that you want to be able to do quick and fast, but yet accurate at the same time. So several different things we can do here. First of all, let's look at adding from the left. So you know that normally when we add the ones place and we carry over and we add the tens place. But if you don't have paper and pencil, you need perhaps a faster way to do that. So when we do adding from the left, we're actually going to add the tens place first, which seems very wrong, but it works. So I'm going to add 70 and 20. Notice I'm not just adding 7 and 2. I have to account for the fact that I'm in the tens place. So I'm going to add 70 and 20 and get 90. And then once I've got that part, I can add the ones together. 6 and 5 is 11. And then in my mind, I can say 90 and 11 is 101. So although I may not be able to do the carrying and the regrouping quickly in my head, this technique will allow me to do it in my head fairly quickly. Okay, let's try this one. Suppose in this case I want to add 68 plus 85, and I'm going to try adding from the left. Okay, so what would I do first? All right, so first I'm going to add the tens, so 60 plus 80, and that's going to give me 140. Okay, now I'm going to add the ones, 8 plus 5, and that's going to give me 13. And now I'm going to add those two things together. 140 plus 13 equals 153. All right, and if you add regular column addition, if you do the standard algorithm over here, you're also going to get 153. It's an accurate answer, just an alternative method. Okay, another one we can look at is something called breaking up and bridging. This one is actually similar, but you break the numbers differently. So instead of considering 70 and 20, I want to think about that whole 76 and just add it to 20, right? So that's my first step. I'm going to add the whole first number to only the tens place in the second number. So 76 and 20 making 96. I've already accounted for that 20. Now I just need to do 5 more. 96 and 5 is 101. So this method, my 7th grader uses this all the time. When he's trying to do things, he will do it in pieces, but he generally does it using this method. This method is very quick for him, and it's an easy way to do it. All right, let's try breaking up and bridging with this same problem. All right, so this time when I get ready to do it, I'm going to consider that whole first number with the tens place of the second number, 68 plus 80, 148. And then I'm going to take that 148 and I'm going to add it to the 5 that I have not yet accounted for, and I'm going to get 153. Same thing as what I got before. Okay, so now one thing to be very watchful of, notice that what I did not do was say 68 plus 80 equals 148, and 148 plus 5 equals 153. While there's nothing wrong with what I said with my words, what I said with my words is exactly what I did right here. Look at what I actually wrote here, equals carries. So I wrote that 68 plus 80 is 153, which is not true. So I need to write this in two separate equations. I do not want to write it like this. So I'm just going to get rid of that, and we're going to do it only this way. Make sure you keep accounted for the fact that equals carries. Okay, so let's look at using compatible numbers. So I have to add this whole string of numbers, and I want a quicker way to do that. Well, I noticed that 130 and 70 makes 200. 50 and 50 makes 100. 200 plus 100, the only thing I have left to add is this 20, so I'm going to get 320. Notice what I'm actually doing is I'm trying to take advantage of as many zeros as I can. Remember how we talked about 0 being the additive identity? So when I add things to 0, they don't change their value, which makes it very easy. 2 plus 0 in the tens place there is going to stay a 2. And if you look back, you'll see that I'm doing a very similar something here. When I'm adding from the left, I'm taking advantage of zeros. When I'm bridging, I'm taking advantage of zeros. So every time I do this, I'm trying to work with as many zeros as possible because the whole point in mental mathematics is to be able to do things easier, and zeros are easier. Okay, let's look at making compatible numbers. So this is similar to what we looked at last week with the idea of the doubles, where you're going to rearrange, or how we talked about making a 10, where you're going to rearrange. The same sort of thing here, except that we're not necessarily going for a 10. We're just trying to find two numbers that I can quickly and easily add because of their composition. They're just easier to put together. So you might not be able to add 76 and 25 really quickly, but I bet you can add 75 and 25. We all know that 3/4 and one more quarter makes $1. So I'm basically just going to move the 1 off of this, consider it as 75 and 25, but remember 100 is not the actual answer, right? This original question had 76 and I've only put 75 here. So what do I need to do to adjust my 100 to get the right answer? Well, I need to add back the 1 that I took away here, right? 76 taking away 1 to get 75, which means I need to add that 1 back in order to get the final answer. So that's the idea behind compatible numbers. In this case, you're not necessarily looking for 100, or you're not necessarily looking for zeros. Neither 75 nor 25 has a 0. However, those are things that we are conditioned to add quickly because of the way our money works. And so that's something that you can add fairly easily. Okay, so let's do some of those same ideas with subtraction. So the first thing we want to look at is breaking up and bridging, which we did with addition. So let's go back and do the same thing with subtraction. So the first thing I want to do is I want to take that whole 74 and take away just the tens place. Notice I'm taking advantage of that 0 because when I subtract with a 0, I'm never going to have to regroup. I can subtract 0 from anything again without changing its value. So 74 minus 20 is an easier subtraction. Notice here I would have to do some regrouping, right? I have to take 110 from the 7 and make this a 14. This I can do in my head, whereas all that regrouping, maybe I can't. So 74 minus 20 is 54. And then I go back and I take away that extra 6. 54 minus 6. So again, I've got some regrouping I need to do here. Some people can do that in their head. Some people are going to choose to break up and bridge this also. And so you'll hear children say, well, 54 minus 4 is 50, and then I have to take away 2 more to make 48. So they're going to mentally take that 6 and break it apart into a 4 and a 2 because that 4 is going to subtract away very easily from that 4, and then I can subtract away 2 more. All right, another method is a dropping the zeros method. So I notice that I have some values here in the hundreds place and the thousands place, and I've got placeholders here. So the way I'm going to think about this one, instead of thinking about 7,400 and 600, I'm going to think about just 74 and 6. So 74 and 6, I can do the same breaking and bridging idea that I talked about here. 74 minus 4 is 70, and then 2 more gets me to 68. Or maybe I can do 74 minus 6 in my head because I memorized that 14 minus 6 equals 8 at some point in the past. Either way, I'm going to get to 68 right there. All right, but again, 68 is not the answer, right? I had to adjust the 74 and the 6 from the original problem. So I need to readjust to get the correct answer. So I'm going to put them back into the place values where they were to begin with. And if 74 minus 6 is 68, then 7400 minus 600 is 6800. So I'm considering this right now not as 7,400, but as 74 groups of 100. This is 7,400, which 7,400 is the same thing, right? Because I could group up that group of tens and go over to the next place value. Okay, so now let's switch gears. Instead of doing mental math, the goal of mental math being to get the correct exact answer, let's do some estimation. So estimation is when I don't need an exact answer. I just need something close. So we have something called front end estimation, where basically you just add the first numbers, 400, 500, and 200. 400 and 500 is 900 and 200 is 1100. But I noticed that that's going to be off because I've got all this value over here in the tens place and the ones place. Front end estimation is usually going to be low unless I have a lot of zeros because I've eliminated the value in the tens and the ones in order to do that. So 400 plus 500 plus 200 is a good estimation, but I can probably get a better one. So I'm going to start off with my same front end estimation. I'm going to add 4, 5, and 2 just like I did to get 11. And then I'm going to consider its place value. That's not actually 11, that's 11 hundreds, right? Because all those numbers are in the hundreds place. Now here's where I'm going to make the adjustment. I'm going to look at what I have over here and see if I can easily adjust it. So 22 and 31, that's pretty close to 20 and 30, which is 50. And 74 up there, that's pretty close to 70. 50 and 70, I'm going to take advantage of those zeros. 50 and 70 add together to be 120. And then what I can do is I can add this value and this value, 1100 plus 120, 1220. So I'm kind of taking away the idea that this is 1100 now, and I'm considering it as 1100 plus 120 to get 1220. So it's not that 1100 is a bad estimate, it's just that you can do a better one without a whole lot more work. Okay, let's look at rounding. So rounding is probably the one you guys are most familiar with. So if I round 7,262, I'm going to get 7,000, right? The 2 tells the 7 to stay the same. If I round 3,806, well, the 8 is going to tell the 3 to go to the next number, so that's going to be 4,000. And 7,000 minus 4,000 is 3,000. So 3,000 is my estimation of this. And because this one went down in value and this one went up in value, perhaps I'm a little bit closer than if both of them went the same direction. Because of subtraction, if they both go the same direction, it actually works out better. With addition, it's better if they move kind of opposite ways to balance out. Okay, using the range is a good idea. That gives you a high estimate and a low estimate. So to do the low estimate, no matter what the digit is in the hundreds place, you're going to choose to leave these two digits the same. So 7,000 and 3,000 give me 10,000. Okay, so just like we did before with the front end estimation, I know that this is going to be a low estimate because both of these numbers are higher than both of the numbers I have right here. Okay, so how about a high estimate? Well, again, no matter what this digit is, I'm going to choose to round up. So the first one will round up to 8,000. The second one will round up to 4,000. When I add those together, I get 12,000. So again, I don't know exactly what the answer is, but I know it's somewhere in between 10,000 and 12,000. It's just a good estimation. Okay, if you're a little bit confused about some of this or you would like to get a little more explanation, look in your text on page 139 through 143. It has more examples for both mental math and estimation, and it has more explanation that you can read to help maybe fill in some gaps from this short video that we talked about here.